Okay, we're doing number 12. This is practice test page 449. This is a kite. Let's scooch this over to about right there. Let's make this. And let's go from here to here. Looks like a kite, doesn't it? Oops, maybe. You get the idea. It's close enough. And they say that this is 3 and this is 4. Now, do you remember how the diagonals intersect each other on a kite?
Isn't it is that whole length across the same length as?
No, there's nothing that's true about the lengths of it, but it forms certain angles. Say it, Rachel. They're perpendicular, okay? So the two diagonals are perpendicular to each other, okay? So that is a right angle right there. So if it's a kite, they intersect at a right angle. Everybody got that? The diagonals do. So, with that said, look, this is 3, this is 4, it's a right triangle, and you're trying to find GF, that's G and that's F. So you're just basically, Pythagorean theorem. Or you could look at it without even going through the whole Pythagorean theorem. You're going to learn this later on in another chapter in this course, but you might have learned this already. If you have a right triangle, if one leg is 3, the other leg is 4, do you know off the top of your head what the other one is going to be? It's going to be 5. Okay, that makes it nice and quick and easy, right? So x is 5. It's a 3, 4, 5 triangle. You ever hear of that? 3, 4, 5. Again, we'll go into that in another chapter. But if you did Pythagorean theorem, let's just do it for fun, okay? So watch. 3 squared plus 4 squared equals, call this x squared. That's 9. That's 16. That's 25. And then you take the square root of both sides, so x is 5. So there it is. So I kind of didn't have to go through all this, did I? If you recognize that you have a 3, 4, 5 triangle, then you can figure out that was 5. Now remember, that's only true if the legs are 3 and 4. Okay, if this was a 3 and this is a 5, that does not mean this is going to be a 4, because the longest, or the hypotenuse, the one that's opposite the right angle, always has to be the longest side. Okay? Yes, absolutely, right. If this was 6 and this was 8, okay, then what would this be? It would be 10. Yep. So we still call it a 3, 4, 5 triangle, but you're right. There's multiples of 3, 4, and 5, and then that would be perfectly fine. Yep. And there's about 2 or 3 other special types of triangles that we learn. The 3, 4, 5 is the one that shows up the most, that you see. Like on standardized tests, if you took the SAT, I haven't looked at the latest SAT or anything, but I could almost guarantee at some point it's nice to know 3, 4, 5. Then you don't have to go through all this mess. Not that that was hard, was it? That was easy, but it just saved you a lot of time, a lot of effort. Okay, we good with that? Okay, so that's one thing we know about a kite, is that the diagonals are perpendicular. All right, let's take a look at number 13. And I know this doesn't have a line down the middle, but I just put it there just to help myself out. Let's do this. It's reflected. Just to kind of make it look a little bit more to scale. We'll do that. And now I can go from here to here, and then from here to here. Close enough. That's not exact, but I can deal with that. Okay, watch. This side is equal to this side. Now it says on a kite, the consecutive, it says 2 pair of consecutive sides are equal. So if these two are equal, then these two are going to be equal if it's a kite. All right. It also says you have exactly 1 pair of opposite sides that are equal to angles. 1 pair of opposite angles that are equal to each other. So they tell you this is 67 degrees and they tell you this is 49 degrees. That means that these two angles right here have to be equal to each other. How do you know which ones are equal and which ones are not equal if you just don't go by the looks of the picture? Well, watch this. Do you see this side is not equal to this side, the angle between the two non-equal sides, you see that? The angle between the two non-equal sides are equal to each other. So that means this is the angle between these two non-equal sides. This is the angle between these two non-equal sides. Those two angles are going to equal each other. Does that make sense? Okay. Now I want to find what those angles are. Let's figure out what the angles are, because that says find angle D, and this is angle D. What do you think?
Well, I added 67 and 45, and you get 116. And
116?
yeah.
You sure about that?
Wait. Sorry. Yeah. And
Right.
then you subtract it from 360.
Good. 360. That's the key, because all four of these angles add up to 360. So we go 360.
That's why I got 160. It's 67 and 49.
So is it 49?
Yeah.
Oh, I'm sorry. My bad. That's why you got that number. Sorry, I just wrote it down wrong. 49?
Yes.
Okay, that's my bad. Alright, so 67 and 49 is, what, 16, 10, 116?
Yeah.
Okay, and then,
You
They're-
subtract that from 360.
Right.
And you get 44, I think.
so 4, it's a 3, right? Is that right? Oh, that's
Yeah.
5, 4, I'm sorry. What am I doing? You're right, 244. That's right, because these two add up to 244, and they're both exactly the same. So you take half of that, divide that by 2, so 122. Does that work? Yeah. All right, so that's 122, and so is that one. All right, good. All right, we good with that? We good with the kite? All right. Again, not the opposite sides are equal to each other, but the consecutive side, like this one and this one, this one and this one. Okay. So you always have one pair of opposite angles that are not equal to each other on a kite, and you always have one pair of opposite angles that are equal to each other. You got it? And we know about the diagonals; they're perpendicular and all that good stuff. All right. And yep, that's it. Anything else? Okay. What else on this practice test? Is there anything else that you want to ask about? Oops.
Is this what the test is going to be like?
Well, I mean, it's a combination of everything we've done. It's a combination of the study guide, the practice test, the homeworks, the quizzes, you know, that kind of stuff. So I wouldn't just study this practice test. This is just one extra thing with some more problems on there. So I would not say that, you know, every problem is going to be on this practice test is exactly like the one on the test. So, you know, look over your homeworks, look over your quizzes, look over, I don't know if I gave you any worksheets or not, but if, you know, gave you any worksheets, look over the study guide, look over the practice test. You know, if you know how to do all that, you should be fine on the test. So this hasn't been so bad, has it? Parallelograms, you didn't ask any questions about parallelograms. Everybody clear on that? All right, and rectangles and squares and trapezoids. What about trapezoids? The mid-segment, is that a problem? That's fairly new. What about the stuff on the quiz? Do you have any questions on the quiz? Does that pass back to you? Most of the problems you got wrong were probably, like, what was that first one? Was it, yeah, if it was a parallelogram, what did they, let me get this. Now, what did they tell you on this? I forget. I don't have it in front of me.
The top and base were parallel.
This one and this one?
Mhm.
Okay. And then this were equal. Okay. Right. A lot of you said that it was that they were that this was a parallelogram. But do you remember what the theorem said? The theorem didn't say one pair of sides parallel and the other side equal to each other. What must be true if you're only talking about one pair of sides? So these two are parallel and what? Equal to each other. So if you had this, is this a parallelogram? Yes, this is a parallelogram. Okay, by having these two parallel and these two equal right here, that's not a parallelogram because there's not enough information. Okay, so you either have to have one pair of sides parallel and equal, right? Or if you didn't know, or you could say, if you knew this, that's a parallelogram, isn't it? Okay, or, and we could just, I think you got the idea. I don't think we have to go through all this. Let me just do one more. What else? If I know that those are equal and these are equal, is that enough to say it's a parallelogram? Yeah, if I have both pairs of opposite sides equal to each other, both pairs of opposite sides, yeah, that's enough to say it's a parallelogram. What else? What if I knew both pairs of opposite angles were equal to each other? Yep, that's enough. Just the angles right there, that's enough. What if I only knew this about the angles? And let's get rid of all these sides. Come on. One more. Okay, what if that's all I knew right there? Is that enough? Nope, that's not enough. All right, I got to know both pairs of opposite sides. You got it? What if I knew that the diagonals bisected each other? What if I knew that this and this were equal and this were equal? Is that enough to say it's a parallelogram? Yep. If I can say that the diagonals bisect each other, then that's enough to say it's a parallelogram. Okay? I don't need to know anything about the angles. I don't have to know about these four sides. All I got to know is that. If I know that, then that's a parallelogram. Okay?
How about, the opposite side is parallel?
And that's all I know? Or what? The opposite sides are parallel? If I know both pairs of opposite sides are parallel, if all I know is that, that's not enough. Is that what you're saying? So if I just know one side is parallel, no, that's not enough. If I know both sides, right, if I know these two are parallel and these two are parallel, that's enough to say it's a parallelogram. That's by definition. Okay? Anything else? I'm trying to get you to ask some questions, okay?
I think you get
Number 8 on the quiz? Alright, listen, let me see your quiz.
Oh, I know it. I just figured that out.
Which one, number 8?
Yeah, Richard, you have to use the Pythagorean theorem.
Yep.
Let me see.
So what'd you have? You had a rhombus, right? So let me I have a rhombus here somewhere. There's a rhombus. Let's copy that. Paste it. I think you put the a squared plus b squared equals c squared. I don't think you did that part the correct way.
You added 25 or something instead of subtracting.
So it says PRYZ, and this is K, right? Now, it says that this is a rhombus, so what must be true about those two diagonals? They must be perpendicular to each other because it's a rhombus. RK is 5, so that's 5. RY is 13, right there. And then, well, don't worry about that. Okay, we're trying to find KY, right? Is that right? RK is 5?
Yeah, and then it's 5 squared plus whatever.
Oh,
squared.
I'm looking at the answer you wrote down as 5. I'm like, wait a minute, that can't be 5. What's going on? So I was looking at the wrong answer. Right. Okay. Right. So you've got 5 squared, and we'll call this, I don't know, just call it little a, right? So 5 squared plus a squared equals 13 squared, or a squared plus 5 squared equals 13 squared. This is another special triangle. Remember 3, 4, 5? This is actually another one, because there's not a whole lot of right triangles that come out where all three sides come out to be a nice whole number. Okay, there's just a handful of them, and those are the special ones that we learned. But if you do this, this is what? 169 minus 25, which is 144, right? Because you got to subtract 5 squared, right? So you subtract 5 squared. So that's 144. Take the square root, and so a is 12. And so that's what that is. So what kind of special triangle would we call this? 5 what? 12, 13. Okay, so this is another one that you don't have to go through the math once you learn it. Now again, we'll take a chapter in another chapter or something. I don't know exactly when it is. let me see. It's not in 7. It's 8. Chapter 8. Okay, we'll go over this in a lot more detail. But there is a 5, 12, 13 triangle. And that's very helpful sometimes, especially if you're taking a test and you're being timed on it and you want to get it finished quick. You look at this, 5, 13. Oh, yeah, that must be 12. Boom, you're done. All right? But we're not at that point just yet. Okay, we good? Yep.
Do you have to know coordinates?
No, I don't think. I'll look real quick, but I don't think I put a coordinate geometry problem on there. But I will look real quick to see. Let me look now.